Welcome to another lesson in general physics. For today's topic, we're going to discuss calculating free fall motion. Let's begin. For instance, you have a 400-gram stone and a 600-gram basketball, and you hold it 4 feet above the ground. Once you release it from rest, both balls will be in free fall. Among the two objects, which one will hit the ground first? Is it the 400-gram stone or the 600-gram basketball? Well, both objects will hit the ground at the same time. This is because they are placed at the same height and are under the influence of the same gravity, or the Earth's gravity. On Earth, the acceleration due to gravity is equal to 9.8 meters per second squared. Taking away air resistance, both objects will hit the ground at the same time. How about a 400-gram stone and a piece of paper? Evidently, the stone is heavier than a piece of paper. Now, with air resistance, which one will hit the ground first? Well, the stone is gonna fall straight down, while the flat piece of paper may go this way, that way, this way, that way, and eventually will fall into the ground. This is because of air resistance. Now, what will happen if you take the same stone and you crumple the paper to make it smaller? Because you crumple the paper, the effects of air resistance to it will greatly reduced. Therefore, when you drop the objects at the same time, it will hit the ground approximately the same time as well. Air resistance increases with the surface area. So if you get rid of air resistance completely, both objects should hit the ground at the exact same time because they are under the influence of the Earth's gravitational force. So a free-falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in a state of free fall. There are two important motions characteristic that are true of free-falling objects. The first one is free-falling objects do not encounter air resistance. The second one is all free-falling objects on Earth accelerate downwards at the rate of 9.8 meters per second squared. So if we have a ball and we release it from rest, it's gonna fall and it's going to accelerate at the rate of 9.8 meters per second squared. Recalling the concept, acceleration tells how fast the velocity is changing every second. So initially, the velocity might be 0, and 1 second later, it is going to be negative 9.8 meters per second squared. Speed can be positive, but velocity can be positive or negative depending on the direction of the object. Since the ball is going in the negative y direction or directed downward, the velocity is negative. Now technically, acceleration is negative 9.8 meters per second. Since it's going downward and Earth's gravity pulls things down, not up. 2 seconds later, the velocity is going to be negative 19.6 meters per second. Every second, the speed is changing by 9.8. So at 3 seconds, the velocity would be negative 29.4 meters per second. And at 4 seconds, the velocity would be negative 39.2 meters per second. So as the ball drops, notice that the velocity is decreasing by 9.8 while speed is increasing. Keep in mind that speed is positive. So at this time, speed is equal to, at 1 second would be 9.8 meters per second. At 2 seconds 19.6 meters per second. At 3 seconds, the speed would be 29.4 meters per second, and at 4 seconds, the speed would be equal to 39.2 meters per second. So an object in free fall that under the influence of gravity, the speed is increasing by 9.8 meters per second, while the velocity is decreasing by 9.8 per second. Now, before solving problems in freefall motion, let's discuss first the equation that will aid you in calculating different variables in freefall. Whenever an object is moving at constant speed, the equation d is equals to v times t can be used. D stands for distance or displacement. Remember that distance is a scalar quantity, which means it is always positive, while displacement is a vector quantity, which means it can be either positive or negative, while v stands for velocity and t is for time. Now, when an object is moving at constant acceleration, the four kinematic equations can be used. V sub f is equal to v sub I plus at. V sub I stands for initial velocity, V sub f stands for final velocity, A stands for acceleration, and T stands for time. Aside from that, we also have D is equal to initial velocity times time plus 1/2 at squared. Also, we have final velocity squared equals initial velocity squared plus 2ad. The last one is d is equal to 1/2 initial velocity plus final velocity times time. Now let's move on with computing problems or solving problems involving free-falling motions. The first one is a stone is dropped from rest on a cliff. So after 7 seconds, what is the speed of the stone? Letter B, what is the velocity of the stone? C, how far does it travel? And lastly, what is its displacement? So before we proceed on calculating let's first identify what are the given. So this is the illustration for us to better visualize what we're going to solve. So there's a cliff, there's the stone, and it says that from rest it was dropped. So what are the variables given? First, since the stone is dropped from rest, the initial velocity is equal to 0 meters per second. And we're looking for its final velocity. Also, time is given, 7.0 seconds, and acceleration is negative 9.8 meters per second squared. It's negative because the direction or the object is dropped downwards. So based on the variables that we have, what equation would we use among the 5 equations given? So we will use final velocity is equal to initial velocity plus at. So solving for final velocity, our initial velocity is 0 meters per second plus acceleration is negative 9.8 meters per second squared and time is 7 seconds. Solving negative 9.8 meters per second squared times 7.0 seconds will give us an answer of negative 68.6 meters per second. So now the question is, what is the speed of the stone? Earlier, I mentioned that speed is always positive. Therefore, if it is the final velocity, our answer, negative 69.69 meters per second, would be the final velocity of the stone, while its speed would be the positive 69 meters per second. Now let's proceed with the third one. How far does it travel? So based on the variables given, the equation that we're going to use is d is equal to initial velocity times time plus 1/2 at squared. So since the initial velocity is 0, let's just cancel that out, or anything that is multiplied by 0 is 0. So 1/2, then our acceleration is negative 9.8 meters per second squared times the time, which is 7 seconds squared. So solving the equation, we'll get an answer of 1/2 of negative 9.8 would give us an answer of negative 4.9 meters per second squared. Then 7 squared is equal to 49 seconds. So negative 49 or 4.9 meters per second squared times 49 will give us an answer of negative 240.1 meters. Now, the question is this for the distance or displacement? Again, distance is always positive, while displacement can be either positive or negative. In this case, the computed answer is its displacement. Since on the problem we are using two significant figures, the final answer should be reduced into two significant figures. Therefore, negative 240.1 meters is converted into scientific notation. So the final answer would be negative 2.4 times 10 raised to the second power meters. Now, as for the distance, since the displacement that we get is a negative number, we're just going to make it positive. So the final answer for how far the stone traveled is 240.1 meters. Converting it into two significant figures, the final answer would be 2.40 times 10 raised to the second power meters. Now for the next problem. An apple dropped from the top of a tree and hits the ground after 3 seconds. So how tall is the tree? Now for us to better visualize it, here's the illustration. Then now we have to get the variables given. Since the apple was dropped on the top of the tree, meaning to say the initial velocity is 0. The time given is 3 seconds. And the acceleration, since it is directed downwards, would be negative 9.8 meters per second squared. Now we have to find the distance. In getting the distance, we have the formula d is equal to initial velocity times time plus 1/2 at squared. Since velocity is 0 times time, so anything multiplied by 0 is 0, plus 1/2 negative 9.8 meters per second squared times 3 seconds. Therefore, computing the equation, we'll have negative 4.9 meters per second squared times 3 squared would be 9 seconds. So negative 4.9 meters per second squared times 9 seconds will give us an answer of negative 44.1 meters. Again, we're looking for the distance, and distance is always positive. Therefore, our final answer would be 44 meters. Now let's move on with the third problem. With what speed in miles per hour must an object be thrown to reach a height of 91.5 meters, or equivalent to 1 football field? Assume negligible air resistance. So the first one, we have to illustrate it for us to find a better illustration if we're going to solve. So we have the object. It was thrown at a height of 91.5 meters. Then it falls downwards. Now we have to get on what is the speed of the object in miles per hour. So the variables given, the acceleration is negative 9.8 meters per second squared. The final velocity is 0 meters per second, while the distance is equal to 91.5 meters. We have to find the initial velocity, and the time taken. So looking at the variables given, what equation do we use? We have final velocity squared plus initial velocity squared plus 2AD. Our final velocity is equal to 0 meters per second. Our initial velocity is unknown, plus 2. Then acceleration is negative 9.8 meters per second squared, and our distance is 91.5 meters. Solving the equation, we'll get an answer of 0 meters squared over second squared is equal to initial velocity squared minus 1,793 meters squared second squared. Simplifying the equation, we'll get an answer of initial velocity squared is equal to 1,793 meters squared over second squared. We have to get the square root of both sides to cancel out the square roots. So initial velocity would be equivalent to 42.3 meters per second. Now we have to convert from meters per second to mile per hour since we are calculating the speed in miles per hour. And able to do that, we have to multiply our initial velocity, 42.3 meters per second, times 2.23 miles per hour as indicated in our problem, over 1 meters per second. Computing the equation, we'll get an answer of 94.4 miles per hour. Last one, if Stephen Curry has a vertical lift of 1.29 meters, then what is his takeoff speed and his hang time, or the total time to move upwards to the peak and then return to the ground? So Stephen Curry is having a vertical lift. From our problem, the following variables are derived. Acceleration is equal to negative 9.8 meters per second squared. The final velocity is 0 meters per second. The distance is 1.29 meters. Now we have to find the initial velocity and the time taken. Looking at the variables given, the equation that we need to use is final velocity squared is equal to initial velocity squared plus 2AD. So let's substitute. Our final velocity is 0 meters per second. Initial velocity is still unknown. Then plus 2. Our acceleration is negative 9.8 meters per second squared. Then our displacement is 1.29 meters. Solving. So 2 times negative 9.8 meters per second squared times 1.29 meters will get an answer of 25.28 meters squared over second squared. Simplifying the equation, we'll get an answer of 25.28 meters squared over second squared is equal to initial velocity squared. To get rid of the square units, we have to get the square root of both sides. Doing that, the initial velocity would be 5.03 meters per second. Now, we already get the initial velocity on our problem. Now let's solve for time. Looking at the variables again, the formula that we're going to use to compute for time is final velocity is equal to initial velocity plus AT. Earlier, we've computed that our initial velocity is equal to 5.03 meters per second. So computing, our final velocity is 0 meters per second is equal to the initial velocity, which is 5.03 meters per second, plus acceleration, which is negative 9.8 meters per second squared times time. Simplifying the equation, we have negative 5.03 meters per second is equal to negative 9.8 meters per second squared times time. So therefore, time is equal to, we have to transpose or to divide both sides by 9.8 meters per second squared. So the equation would be negative 5.03 meters per second over negative 9.8 meters per second squared. Solving the equation, we'll get an answer of time is equal to 0.513 seconds. Now, the time that we have computed is not yet our final answer. We have to compute the hang time. And when we say hang time, we have to find the time to the peak and then double it. So 0.513 seconds is only the peak time. So we have to double it. Therefore, the equation would be 0.513 seconds times 2, giving us an answer of 1.03 seconds. Therefore, Stephen Curry has a takeoff speed of 5.03 meters per second and a hang time of 1.03 seconds.